Okay, fantastic. All right, so I'm recording this now. Okay, so so I attempted to plot a simple sine graph. So when you're plotting a sine graph, of course, you have to define your x-axis, your y-axis, and then you can now plot the graph. Okay. So yeah, I defined my x-axis just numbers from 0 to 15, and then I was splitting this range in 100 numbers. So I'm putting 100 numbers from 0 to 15, and then I'll find the sine of all those numbers. Okay. So you can see this is 0 to 15 here. Okay, and then so each node, this is 1, this is next value, this is next value, this is next value, and then I'm finding the sine of each of those x's. So I'm finding the sine of each of them, and then I can see, as you can see, it plots a simple sine graph. Okay, so again, this is my x range, this is my y, which is the sine of x, and then my plotting, this is function or the method to the plotting. Okay, so I define my x, so I just pass it here. I define my y, and this is like a marker, okay? If I leave it this way, it's just going to plot a simple line graph, like as you can see here. So you have different markers. If I wanted to plot, dashed lines, I can do something like this, and then plot dashed lines. So if I wanted to also plot something like this, okay, there's nothing like that. Let me do something like this. Okay, yeah, this is what I was looking for. So if I wanted to plot lines filled with dots, so at every point I put a line, I can do that. You can also write O instead of dots, and it makes it bigger. Oh, come on. Okay, so it makes it bigger. Okay, so you can do a lot of stuff with that, and then these are just basic stuff you can do. When we get to matplotlib, we'll talk about it in more in-depth manner. So finally, we also try to look at the random method, okay, because there are times when you just want to experiment and you want to create random values and just play around with it. So maybe you want to create a fictitious data and you just want to populate it with random numbers from Python. It's good practice to allow Python to do this thing for you rather than you trying to figure out what to do yourself. So you can use this random method. Okay, so what it does pass in there is the size. Okay, and Python just creates random numbers for you between 0 and 1. For a normal distribution. Okay, so that was that. So I tried to create a 4x4 matrix, so a 4x4 array, and then randomly created numbers, and then I had to use random dots random. Okay, so it's not inside this random function. There's another function again called random. So there's also what we call the rand ints. Okay, and this time you can, if you notice, these are floats between 0 and 1. But if you want to create numbers, okay, within a range, so if you want to create random numbers within a range, I can use this rand ints method. Okay, so I can use rand int method, and then how do I do that? I pass in my beginning. So what should be the lowest number in my matrix? Okay, and the next thing I'll pass is my ending number. Okay, so what would be my ending number in this matrix? So if you notice, I wouldn't get any number greater than 4. I wouldn't get any number less than 0. And then the last thing I'll do here is just the size of my matrix. So if I'm creating a 2x3 matrix, as you can see, it has 2 rows, 1, 2. It has 3 columns, 1, 2, 3. And then that's that for that. And then lastly, we also attempted to create, of course, numbers that are just basically, following this normal bell curve distribution, and then giving the size between 3 and 3. And so this is creating a 3x3 matrix that can be negative or positive. Basically, any kind of number that follows this normal distribution curve, okay, which is basically bell curve shape. Okay, and then that was that for that. So let me give out time for anybody that may have questions. So if you've got any questions, do let me know right now. Any question, just a comment or issue around, or maybe if you didn't understand some of the things I just discussed right now, and then you want us to talk about it, or you want us to just clear a gray area. Any question? Anybody? Okay, let me move on to other interesting stuff. Okay, so one thing about NumPy, like I said, is that it is a kind of way of converting lists to matrices. But if you want to be professional, you can call them NumPy arrays. So you can do most of this basic mathematical stuff you do with maths, also with matrices. So you can add, you can find a transpose or a matrix. You can do multiply a matrix, and also let's talk about all those things. So if I want to say add, I use this np.add, okay, np.add, and then I just it takes into two NumPy arrays. So let me create two NumPy arrays. Let me call the first one A. So let me say NumPy.array. Okay. Before that, let me talk about another method I didn't talk about, which is the reshape method. Okay. There are times when you want to change the shape of an array. For instance, let me create a simple NumPy array. So let me say np.random random. Okay, the roundings. Okay, so like I said, this rounding does take numbers that you want to you want to play around with. So let me just say I want to play around numbers from say 1 to 10. Okay, if I run this, okay, I should pass my size. If I need pass the size, just give me. So let me say I'm taking 1 to 8. Okay, so you just created random numbers from 1 to 8. Okay, someone said something in the chat. Okay. Yes. Well, I wouldn't say NumPy itself is like matrix, but NumPy array, yes, can be seen as matrices because they're basically used for carrying out computations, mathematical computations. I said that actually NumPy means numerical Python. That's the meaning of NumPy. So it's a way of bringing all these things, calculations, linear. That's why it's good in data science because when you're dealing with when you're dealing with real numbers that you want to calculate, maybe sum, mean, all those things, you'll be using NumPy a lot when you're dealing with EDA, exploratory data analysis. Okay, so someone said, how do we import NumPy? Okay, the importance of matplotlib library, please. Okay, we'll get to matplotlib. I just wanted to show how we can plot graphs, but we are not yet. We've not gotten to matplotlib yet. So maybe after NumPy, we'll deal with pandas, and come from pandas, we'll talk about matplotlib and seaborn. And then once we are done with that, we can delve fully into sklearn. That's where the fun stuff is actually. That's where you can start building machine learning models. So I really can't wait to get there. So for now, let's just stick to where we are. So I said, if you want to if you want to import a library, for those that were not in the last class, let me explain what these libraries are. Okay, so thing is, Python is an open source programming language, and that means that anybody can develop a code, right? You can even add, you can contribute to all these codes you are using. But actually, Python was not written in Python. It's confusing, right? Python was written in C++. So don't think because you know Python, you'll be able to add to what they are doing. Except you know C++, you really can't add much to what they are doing in Python. Okay, so Python was written in C++ anyway. So, but the idea of what I was trying to bring up is that because it's an open source language and people contribute to it, people writing codes or create functions that do stuff. Okay, so rather than you doing everything from scratch, you can just use functions, or you can use let me say functions or classes that have been created already. Okay, so if for instance someone creates a class to calculate the mean, I can calculate the mean of this number, for instance, right? I can do it. But for instance, in NumPy creates a method that helps you calculate the mean. So rather than me, oh my God, this was my fear. These guys are telling me I have 10 minutes left. So maybe we'll run out of this meeting and then come back. Okay, so let me continue what I was saying. Okay, so rather than me, okay, that has confused me. What was I saying? Okay, I was talking about libraries. Okay, so rather than me creating these things from scratch, right? I can just use what has been done already. And then what most people do is that they put those things in libraries, or they call them libraries. Some people call them modules. Okay, some other call them frameworks. So there are a lot of fancy words in Python. You just have to get used to them. Okay, but I think I prefer library. So in these libraries, people create, like for instance, NumPy is a library. So they have many things inside this library that you can use. So to use a library, use the import statement. Okay, so you import NumPy. because I'm using NumPy library. But as I said, when you're trying to use any class from this library, you have to do NumPy dots. So this is like you're trying to access a method or a function inside this library. Okay, so if you remember when we talked about OOP, scroll up maybe. Okay, so if you remember when we spoke about OOP, so after we instantiated this class and we wanted to call one of the methods, we have to use dots. Then we called this method we created. Okay, so this was the method we created, and then when we wanted to use it, we had to what? First off instantiate the class and then call the method using this dot operator. So when you see dot, it means you're trying to call a method. Okay, so to call any method, I have to use NumPy dots. Okay, so for instance, I want to do the main of any operation, I'll do NumPy dot main. Okay, all those stuff, or STD, standard deviation, all those stuff. But really, most of the time, because this is a lengthy word, people don't like to use it this way. Okay, so what most people do is that they import NumPy with an alias, and then by convention or by popularity, let me not say convention, everybody uses NP. So you import NumPy as NP. Okay, so that means that anytime I want to call any function or any functionality in NumPy, I'm just going to use NP dots rather than NumPy dots. Okay, so I hope that makes sense. So yeah, I was saying that you can use NumPy for a lot of stuff, and I was trying to explain shape and reshape. So yeah, I created this NumPy array. Let me call it X. Okay, so let me run it again. Good. Okay, so let me clear this off. I've imported it already before. So this I stored this index, this matrix now in this variable X, right? So if I say X, come on. Okay, so if I say X, you can see it printed out the random numbers I created from 1 to 10. Okay, so now, one thing you can do, which is also very useful, is to check the shape of any, maybe you have a data or something, you check the shape. So the shape just tells you the number of rows you have and number of columns you have. So if I try to type the shape, for instance, shape is an attribute, not a method. So you don't call it. It's just an attribute. Okay, so I'm mindful of that. So I do NumPy.shape. You can see that this has one row, okay, one row, and then 8 columns. Okay, so that's that. Now, if for instance I want to change the shape, okay, what you can do is what we call this reshape. Okay, this reshape method, and then what this reshape method does is just to change the shape of your matrix. So like I mentioned, if I do X of shape, you will see that this has shape of 1 to 8. But let's say I want to change the shape of this array to have maybe 2 rows and 4 columns. Okay, so I can do X dot reshape this time. Okay, so if I do Shift and Tab, you see the doc string of this, and it's asking me, as you can see, the first parameter it requires right now is the shape I want to use. Okay, so look at it. What does this method do? It said the method returns an array containing the same data with a new shape. So what this does is just to change this from the shape it was to a shape you want. And then you can see an example here. Okay, so this is also a good thing to do when you're dealing with data. It's always good to read the doc string. And like I mentioned, there are 2 ways of doing this. You have a very fast system. Once you do this, once you type in the method, okay, without putting in this, even when you put in this, you can do it. Just type Shift and Tab on a Jupyter Notebook, and it creates, it gives you the doc string. So this is like the official documentation from NumPy on how to use this method. Okay, so sometimes when you're confused as to what a function does or the kind of parameters it requires, okay, so you can do that, and then you see all the documentation. So you can see it takes in parameters, shape, and other. Okay, so you can read about all the stuff. Then you have it. So let's get back to what we're discussing. So the other way of doing it is also, so if you don't have a very fast system where it's not so responsive to what you're typing, you can just put in the question mark. Sorry, what's my question mark? Okay, this is my question mark. So you can put the question mark after typing in the name of the function. And so this time you have to run the code. So I just run this. So if I run this, it also creates or it returns the dot string for that method. Okay, so as you can see from dot string, right, it needs the shape of the new shape you want. So let's say I want to change this to a matrix that will now have a shape of 4 and 2. Remember, this was 1 to 8, right? So okay, let me print this. So you will see print, and then let me print the matrix again. So you also what's going on. So I printed the shape. It was the shape. Let me just print space, print all this just to make it nice and smooth. So I'm not confusing anybody. And print under space. Okay, so you can see here, this is like, this is the shape, okay? And then this is the matrix itself. Okay, so now let me reshape this matrix. And so I'm just going to run this code. Okay, so I run this. Okay, so if I run this, as you can see, it has reshaped this matrix. The matrix was all in one line. Now it has been split into line. What you may not see what's going on under the hood because of how it was written. But if let me recall this to the X, okay, and then let me run this. So let me now print out this same guy. Okay, so I just copy you like this, and then just what did I do? I copy you, and then I paste you. Okay, so you can see this time they are all now in rows and columns. So this is 8 8s in one row, okay, 4 7 9 7 5 8. Before they were just 8 8 4 7 all in one row, but now we have 4 rows. Sorry, we have 4 rows. Was I saying? Okay, maybe I wasn't saying the other way around. So now this is 4 rows. Okay, 1 2 3 4, and 2 columns 1 2. So this is particularly important when you start dealing with CNN and all this stuff, because if you're dealing with CNN, which has to do with creating convolutional neural networks, and that's where you have to do with stuff that maybe you want to do image recognition, image captioning, or image captioning. Yeah. So you want to from image create a caption. So when you're dealing with images, basically, you would need to understand how to reshape the images, because by default, the images come with the shape of, I think 255, 255, 3. So this is the number of, well, it depends on how quality your image is. So this is like number of pixels in the x-axis, number of pixels in the y-axis, and this is the number of channels you have. So most of the time, images do have channels of, they have channels in RGB. Okay, so you have 3 channels. You have the red channel, you have the green channel, you have the blue channel. That's for colored images anyway. So the other way you can play around with this is to, when you're dealing with convolution neural networks, it's always good to change these images to change the shape, of the image to have four inputs, and that's how neural network work basically. So you have to reshape this guy to have another, channel or another dimension basically. Okay, so the reshape method is very important. So I need to talk about it. So guys, we'll be going off very soon because I can see less than a minute. So on the WhatsApp group, I'm going to create another link, and then I'll send it to you. So we'll continue from there. Okay, so let me just allow this go off, and then we'll continue from there. Okay, so that's that for that. So I have explained this reshape. Okay, so I'm going to use it. So let's say I have matrix. Let me just say mp dot random dot. Okay, let me just say mp dot a range. Okay, so a range of say 2 to 10. Okay, check the length of this. Let me check the length because I want to make sure it's something I can reshape easily. Okay, let me make it to 11. So it's something I can shape to a 3 by 3 matrix. Okay, well, there's one thing there's one thing I want to point out. Okay, so in this reshape, you notice that I had to reshape it in a way that it is acceptable. Okay, now I had 8 numbers here, right? I had 8 numbers here, 1 to 8. If I'm reshaping, I shaped it to 4 to 2. So the question is, what happens if I shape it to a number that is not a multiple of? So if I wanted to reshape to say 3 by 3, that should accept 9 numbers, right? So let's see if that will work. Okay, makes sense. It's telling me I can't reshape an array of size. It's in shape of 3 by 3. Okay, so it's something you should take note of. So when you're reshaping, you really can't reshape a number that would not be it won't fill the matrix up. So it has to fill up the matrix. Yeah, so that's one thing you all must take note of. Okay? It's a very big stuff to take note of. It won't work. So let's go on now, and then so I'm calling this matrix X, and then I'll call this matrix Y. So this NP of A range of say 11 to 20. Yes, this is okay. So let's run these 2 things. Okay, so let's say I want to find the mean. Okay, so I do the NP of mean of X. Okay, and then it gives me the mean. So the mean of numbers from 2 to 11 is 6. Okay. If I want to do np.sum, so these are just basic mathematical stuff that you can do. That's what I'm trying to explain. So you can see it's asking me, so what do I want to sum? So I'm solving X and Y. Okay, so if I do summation of X and Y, it gives me 189. So you can do a lot of stuff. If I want to find the multiplication, the dots multiplication of matrices, okay? So those multiplication we used to do, right, in elementary mathematics. If I run that, oh yeah, okay, this should have been, this is not like a shape. Okay, so repeat that dots. So look at this actually. So that sometimes it's always good to check the dot string, so you know the kind of arguments that method is expecting. So if I check it, it says it does the dot operation of 2 arrays, okay? Specifically, so let's read it. Okay, specifically, say if A and B are 1, they are its linear product of vectors without any complex conjugation. Okay, so if A and B are 2 arrays, so it is matrix multiplication. So all those matrix multiplication you do. Okay, so you can read all those things. So it's asking for 2 parameters A and B. And then what are A and B? Said A and B is just like an array like. Okay, is my first argument, and B is also an array like and the second argument. So it's basically asking for 2 arrays. I already defined 2 arrays there, X and Y. So if I say I want to do matrix multiplication, you can also do X, Y, X dot Y, sorry, yeah. X, Y, sorry, what am I saying? So it's like this is my first argument, this is my second argument, and then it does this. But I think I should, let me reshape this guy so it looks into it interesting. So if I reshape this to be a 3 by 3, 3 by 3, and then did I put that somewhere? Come on, should I put this, and then I reshape this as well, and just copy it. Sometimes copying and pasting is your life. So okay, so I do that. So you can see now there's something more interesting. I include X and Y, so it sounds nice. So I print X, print Y. Let me put the spaces between. So print an empty space, print another empty space. Okay, so if I run that, you can see the first thing was this was my X array. Okay, this is my Y array, and then this is the multiplication of X and Y. So if you don't trust Python, you can actually do this yourself. So you can try it out and then just do all those things, all those naughty things I wouldn't say they are naughty, but I mean, those are very problematic stuff in secondary school, doing matrix multiplication. So that's that. So NumPy can help you with a lot of little common stuff that you would be needing when you're doing data manipulation. Okay. Okay. So there's one thing I would like to also talk about, and that's maxing. Okay. So when we talk about maxing, what we are doing in maxing is just to try to filter based on some conditions. Okay. So let me print my Y array again so you guys know. Okay, so this is my Y array. Okay, so these are those numbers. You can see 11 to 19. Yeah. So if I say I want to only print numbers that are greater than 15, so maybe you're dealing with a column in the data, and then you only care about a number that is above or below a particular number or a particular range, or a number that is exactly equals to that range. Okay, so I just want to know the numbers that are equals to that range. Okay, so one thing I can do is just to, if I say something like y, okay, greater than, let's say greater than 15, it will print a Boolean. Okay, so it will fill up these matrices with Boolean. So in cases where y is greater than 15, it tries true. And in cases where y is less than 15, it prints false. So if you don't trust it, run that. Okay, so you can see that it still returns an array, but this time it filled up my array with truths and falses. Okay, so one thing we can do again right now is down to print out only entries that fulfill this condition, and that's what's called masking. So in masking, we are trying to print the same data frame, but not everything right now. I'm putting the data frame that is based on, right? Okay, what's this on my screen? Okay, so we are printing the data frame, okay, that is that is greater than, I think I've turned off. So I'm putting a data frame that is greater than 15. So if I want to do that, what I'll do is just like indexing in lists. So I'll first call this guy, and I'll see that I'm indexing it. Okay. And then I will now pass in this Boolean, this filtering method that is like passive in here. Okay. So remember that if I did this without doing this masking, it's just going to print out trues and false. But here, it's only print out the entries that are true. Okay? So in this case, it's only for my data, it's only printing entries in my data frame. Sorry, not data frame right now. It's only printing entries in my it's only printing entries here that is true. So if I run this, you see that you can see it's only printing 16, 17, 18, and 19. Okay. So it's not printing anything more. So if I do is equals to 15, okay, you see that it does that for me in I can also add other things. So I can say, oh, okay, is equals to 19. Okay, well, apparently it says it doesn't take more than one argument, so I can't use this all here. I was trying to be ambitious. But anyway, so you can do, okay, just one argument it takes, or yeah. So I can do less than as well. I think I've done better than, and then you print out numbers that are less than, right? Yeah, less than 15. So that is maxing for you. That is maxing, yeah, for you. Maxing. Am I saying it right? I really don't know if I'm saying it right. Anyway, sometimes S and K can give me problems. Risk. I said that right. Okay, so now let's press on. So I wouldn't want to play around with NumPy because the thing is there are a lot of things you can do with NumPy, and then sometimes you will use majority of those things. So I'm going to just say that'll be all for NumPys, and whenever we want to use anything in NumPy, I'll just explain that method going forward. Okay, so now let's move on to the second part because I think we are also we are time conscious right now. So let me change this. So let me change to this 6. Okay, great. So let's talk about pandas. So I'm going to call that a markdown. So pandas. So let me change to markdown. and then I run it. Okay, so yeah, now let's talk about pandas. Now, pandas, for instance, you can see that NumPy work basically with one-dimensional or most two-dimensional arrays. It can work with other dimensions, but it's not good for visualization. So in pandas, you create something we call data frames. Okay. Well, in pandas, you can also create series, but you deal with data frames and series in pandas. And putting it in simple words, a data frame is just a table. Okay, so if you see a table, maybe a data on a Excel spreadsheet, that can be seen as a data frame. That's what a data frame is about. So, but I don't want you to see pandas as just data frames because you can also have series in pandas. Okay? So a series is just like a data frame with one row or a table with one row. That is a series. Okay, so let me just explain how to create a series. So like I said, a series is just a data with one row. So if you want to create a series in pandas, first of all, I have to import pandas. So let me do import pandas. Sorry, import pandas. Okay, but like I said, most of the time they don't use pandas like that. So they use an alias. The alias they use for pandas is PD. So when you're importing pandas, it's we normally import pandas as PD. So let me run that. Okay, so that has run. So now we can use the various stuff in pandas. So the first thing I spoke about was trying to create a data frame or a table with one column, a table with one column. And I said that it's just what we call a pandas series. Okay, so if I'm to create that, I'm just going to use this series. Okay. This series method. Now, please be careful. This series has what a capital letter S. Okay, it's not like this. Python is case sensitive. So these are little mistakes guys make. So it's capital letter S. Okay, so now let's check the dot string so we understand. So it's asking me the data, the index, and all those stuff. So remember, I said a series has what? One dimension or just one row. As you can see, it's a one-dimensional ND array. Okay, so as you can see, this is ND array. What does this ND mean? N-dimensional array. Remember the NumPy we've been doing? NumPy we've been creating. They all add what type of ND array. What does that mean? Pandas work with NumPy. Okay, pandas accept NumPy. So Panda is actually built on top of NumPy. As I most of the time, whenever you see pandas, you always hear NumPy. But wherever you hear NumPy, you always hear pandas. Because both of them work together. They are built on top of each other, like they are dependent stuff. In fact, you can't run pandas without having NumPy installed on your machine, right? It will work. Okay, so now let's get back to what we're discussing. So this is just going to create a simple one-dimensional array or a table with one column. Put it in simple words. Let me just create a table with just one column of 1, 2, 3, 4, 5, 6. Okay, so if I run that, you can see it's like a table. Okay, this is what we call the index. Okay, the index is also something very interesting and important. So this is like the index. I'm not able to highlight it, but this guy here is my index and this is my number. So I think it will be confusing. Let me change this to strings. So let me pass in strings. So let me say this is Ade, this is Toby, this is Liam. Anything that comes to my head, guys, not asking. This is Jane, my baby, Jane, my girlfriend. So this is Rash. Okay, this is Calf, whatever. All right, so this is just a list of names, right? I think this is nicer. So this is just a list of names. Okay, so around this, you can see now that this is an index. By default, pandas create an index for you. So it starts indexing from 0. So this is just like when we are writing, maybe we are writing attendance in school. I know a lot of us went to schools where they will say, come for this class and else will take it. When you're writing attendance, to the left, you see everybody writes numbers. So you have number 1, your name, maybe your matric number, and all this stuff. Number 2, your name, matric number. So that's what this index is about. Just like numbering these guys. So if you want to say access a particular, want to access a particular number, you can use the index to access that number. We'll get to all those stuff, indexing, In fact, we would have talked about indexing in NumPy, but we can also talk about it in Pandas. So there's no big deal. So we'll talk about indexing here in Pandas. So yeah, that's for that. So what you can also specify your index. So if I don't want these guys to have this particular index, maybe I want some different index, I can pass it as well using this index. And I'm just going to take a list of indexes I want. So say I want my index now to be B. Okay. So sometimes when your code is getting very long, it's always good for you to break it. So after a particular argument, you can press enter to just make your code neater. So instead of you writing everything in one line, you can just press enter and then breaks your code for you. Nice and sweet. So let me continue. A, B, C, D, E, F. How many? Good. C, E, F. So this is 6, right? Good. I run this. I think I made a mistake. Okay, there are 5. How many? 1, 2, 3, 4, 5, 6. Now 1, 2, 3, 4, 5, 6. So now if I run this, you can see that the index has changed right now. Okay. So sometimes you may want to change your index to something you want, and then you use it says. But in practice, you most of the time don't use series. Okay. You use data frames. Okay. And by the way, if I want to access anything with in series, okay, let me call this my let me just call it table 1. I don't call it X and Y this time, so let me just use table 1. Okay, so I run that now. So if I want to maybe access the value inside this C, what I just is as if I'm doing indexing. Yeah, I'm leaving you guys doing indexing. So I open a square bracket like this and then just put C, right? Sorry, this should have been a string. Okay, so if I call, calling this index now, this is like, what is this index? This index is C. Okay, so if it checks, okay, under this index, it's printing Liam. So I think what I can do to make it a little bit interesting is to print a table for you to see. So if I'm printing table 1, okay, so if I now access the C index, you can see C is not, sorry about that, C is Liam. Okay, so that's what I also talk about to do some more sophisticated indexing when we get to data frames. So now let's talk about data frames because really you rarely use series because I mean you hardly use data with just one row. It has its place, but most of the time you use data frames. So you also create a data frame the same way you create a series. Okay, so so if I want to create, for instance, data, let me just okay, let me type it, let me do this. So I do pd.data frame now, not series. Okay, pd.data frame is a method to use. Remember when I'm trying to create a series, I use pd.series. And I'm trying to create a data frame, I use pd.data frame. Now take this, D is in capital letter, F is as well in capital letter. So this will not work. Okay, but this would work. Is an empty data frame, for instance. Okay, so there are different ways to actually create data frames, but I think if you ask me, the easiest way is to create data frame from dictionaries. Okay, that's to me the easiest way to create data frames, and then we'll do that right now. Okay, so let's create a data frame that will say old someone's name, email, and then maybe phone number. So we'll create a dictionary. So let us call that df dicts. Okay, so this is my dictionary for it's my underscore. So let's get some problem. So remember you create a dictionary with the curly braces. Okay, so you have your key and you have your value. So the first thing is name. Okay, this is name. Okay, so what's the name? It's not okay. So let's say it's David. For lack of think about it. So the next thing I can take is email. So let's say email, yeah, is David at gmail.com. The next thing I can take is telephone. Okay, and then I'll pass that as a number. So I say 1, 2, 3, 4, 5, 6, 7, 8. Okay. Okay, so now I wanted to call it DFT. Okay, so now I've created my data frame. I've created my dictionary, not data frame. So if I want to, turn this dictionary into a data frame or a table, all I can do is just to pass this dictionary, right? I pass the dictionary as an argument. I pass it as an argument. Okay, so if I pass it as an argument, what is this? Oh, it's actually me. I must pass an index. Okay. Okay, so well, it's asking me I must pass an index. So the thing is, this would have created this table as name will now be David. Okay, email will be david@gmail.com. Telephone will be this. So you can see this thing I just did right now as user 1. Okay, so if I want to create more users, I can create the same dictionary or a list of dictionaries and call it user 2, user 3, user 4, user 5, user 6. So because this is just one entry, let's create an index called user 1. Okay. That again. Come on. User must be a collection of some kind. Well, okay, understand what's going on. I think I got confused with the arrangements. So these are like, let me just give it some index. Let me just call it list of ABC. So you guys will just see how this is and how now explain. Okay, yeah. So this is what I wanted to happen. No, I don't want this. Just a minute. This is not what I wanted to do. Okay, I guess I should have done this to the lists. Okay. Again. Okay, it should be a list of dictionaries. That's what I wanted to do. Just give me a minute, please. Okay. Well, this wasn't what I wanted, unfortunately, so it's confusing me as to what is going on right now. I'm really confused right now. But come in, let's give it a moment, guys. I don't know why it's printing this 3 times. 1, 2, 3, why? It's printing it 3 times. 3 times, why? Why is that? Or should it have been a series? Oh my God, on the sides. It's a series. Anyway, well, you hardly use this. So well, don't get too bothered about this. But one thing you can do, which I also wanted to say, is that I was trying to see how we can pass in. You can change data frame, or you can change dictionaries to data frame, which was what I wanted to do. Okay, another thing you can do to create a data frame or a table, as you see, is to also pass in lists. So let me just pass in some simple list here and then You see the result. So you can see that I created a list with just one column, but 4 rows. 1, 2, 3. Okay. And then you can define the index of this list and the column. So if I wanted to define the index of this list, I can just use this index. Okay, so if I want this index to be ABC rather than whatever it was, I can pass it as ABC. Okay, so I run this. What is this specification? So I've turned it to a list. Sorry about that. So yeah, so as you can see now, the index is now ABC. Yeah. So one thing I can also do is also define my column. Okay, so this is one column, and the column was default, was given a column name of 0 by default. So one thing I can also do is to pass in, the column method. Okay, and then the column method just takes in whatever I want on this column. So let me just call this column user 1. Also, this. I should put the comma. What is that? What's going on? What is going on? Index must be. Why is this guy not running? It's something wrong with my. It's something wrong with my. Oh dear, this is not good. This should run easily. I don't know why it's not running. Columns. Okay. Should be using 1. Okay, I guess it should be a list. Wait here. See, guys, sorry about all this. The thing is, in Python, well, some little things can embarrass you, and it can be very embarrassing. Columns take lists. Okay, so I have to pass because there are situations where, for instance, I'm creating more than one. I'm creating more than one column. Okay, so it has to be a list of column names. Okay, so this is for creating. Of course, the index also must be a list. So I can. Okay, let me not confuse it. Let me change this list that you all want. So this is the list of A, comma B, comma C. So it's the same thing. Okay, so what I was trying to point out was that in situations where you have more than one columns, as we see, you can create this for you can create different columns. So let's see situations where we can have more than one column or one row. So in those cases, of course, to be like a two-dimensional array. Okay, so remember I said in series it takes one-dimensional, so it's just going to be a list. But when you're dealing with data frame, it's like a table. So you have a row, right, and a column. So if I'm creating a data frame, for instance, I have to create a data frame with 2 dimensions. Okay, it's have to open 2 square bracket, as you can see. So I'm opening a square bracket to show that this is like my first list, so to speak, and then my second list inside my first list. Okay, so I can now create my list of numbers. So I can say 1. So 1, 2, 3. Okay, I'm going to close this. So this is like my first row. Then open another one. Okay, and then 5, 6, 7. Close it. So if I want to create another one, I can say that's 7, 8, 9, and I close it. And then remember, I'm just closing this inner list. And I have to close it the second time to close my outer list. So let me break this guys so it's easier for you to see. Okay, so right now I have a 3 by 3 matrix. Let me print this matrix for you outside so you guys can see what the matrix is like. So if I print out this matrix, as you can see, it's like a 3 by 3 is my first row. Okay, this is my second row, and this is my third row. So in this case, I'm going to have 3 index and 3 columns. Okay, so I have to pass in. If I run this right now, I'm not going to run because I just have one column. So I have to pass in a list of 3 different columns. So let me just say this is user 2. This is user 3. is 3. So like so. So if I run this right now, you can see it has created. This was what it was, okay, on a normal day, but with the data frame, it has been turned into into a table. How would that make sense? Okay, so let me know if you guys have any question, because I know the past few stuff has been confusing. So let me know if you guys have any problems with what I've done, because I want to talk about what we now use the most. Because most of the time you won't create your tables like this. You just import your table, and that's with CSV in CSV format. So that will be the last thing I'll talk about. But you have less than 6 minutes. So I'm just going to talk about that, and then tomorrow we'll talk about some other things in Pandas and then get into Matplotlib and Seaborn. So as I was saying, that the last thing you would like to do right now, or most people, in most situations, the things you do is to import your data. Okay, so most of the time, for instance, now I created this data myself, right? But this is not what you do most of the time. Most of the time, what you do is to import the data. And then for data set in data science, you use data in CSV format. Okay, so CSV format are just like Excel spreadsheets. So it's like another format of storing data, but this time not with Excel spreadsheet, but with comma separated values. So each of those columns or rows are separated by commas. So let me find the simple data to show you that. So in my desktop, I have a data called the iris data. I'm just going to use that data as an example. Okay, so now, well, to read data or to read data in CSV format, use the pd.read CSV. Okay, pd.read CSV. This is the method using most of the time. Trust me, that all these ones I'll say was just to show you how to create data frame from scratch. But you won't be creating your data from scratch, okay? You won't create your data from scratch. What you do is to import the data. And this is what we're using most of the time. So in this CSV format, it takes in the parts where the data is. So by convention, we'll put in this arrow. Okay, then I already copied the parts anyway. I copied the parts of the data. So I just pasted the part here. This is the part where the data lies on my system. So it's on my desktop. Inside this folder called dataset master, and the name of this file is pd is iris.csv. So if I say store this as a variable called data, and I try to see data, you see that this is my data set. Okay. So you see that this is what you use most of the time. So this is a data set, of course, that shows the species of a plant based on its sepal length, its sepal width, its petal length, and its petal width. So we have 3. This would be like the first data set to use in this class. So you have 3 data. So you have the iris.setosa, you have others which we'll see. So you have iris.virginica, and then some other ones. Okay, so this is my data, and I use this pd.read CSV to read data from your folder from your system. So maybe in the next class I'll send data on WhatsApp, because we use data for a lot of stuff to play around with. So but most of the time, people just try to inspect data because we have very long data to consume in our space. You can see here is just data with 150 rows, but you can see how it has consumed in our space. What you can do is to use this shape head, sorry. So if you use this head method, it prints out the first 5, the first 5. I think there's a problem. Okay, well, we're running out of time already badly. But let me just round off with this. So, like I was saying, you can use this add method to check for the the number of rows, the column names, to see what is actually inside your data before you start to wrangle your data. Okay. So that's that. So guys, we're running out of time already. We'll be sent out of this meeting in less than 5 minutes. So let me just ask. Let you guys ask questions. So I'm taking questions from guys. If you have any question, please let me know. Okay, let me see the questions there. So someone is saying, how do you call out the dot string? Okay, so you call out the dot string with shift and tab. So you press shift and tab together, and then it gives you the dot string of the of the um, of the method or whatever function you're trying to use. So let's go on. Okay, I guess that's this only serious question. Okay, yeah, someone asks, is slicing applied in pandas? Yes, slicing is applied in pandas. And then we'll do all of those iloc and loc maybe in the last class, because right now we're running out of time. So guys, any question? Any question? I had issue with that, so it's all stripped off, everything stripped off or something. It's crazy.